Grüezi YouTubers. Here is the guy with the Swiss accent again.
Which Arduino compatible board is the fastest? And which needs the least energy for the work? You will see the first race between boards in the below $10 class. The race is started by a start button and finishing flags show the winner. The race is organized in 2 runs. The first run consists of some integer arithmetic, conditional branches and I/O operations. This race simulates code used in day-to-day situations like controlling relays or reading sensors. The second race is for number crunching. The boards have to calculate results of a formula using floating point math. This race resembles code used, for example, in GPS data calculations. The race is very simple. Wait for the start button to be released, calculate 100,000 times the benchmark, and raise the flag.
But who are the racers? Board number 1 is an Arduino Pro Mini compatible board with 3.3 volt supply voltage and 8 MHz clock speed. Number 2 is the same board with 5 volt supply voltage. It has 16 MHz clock speed and therefore is expected to be faster. Number 3 is a Maple Mini board with an ARM processor and 72 MHz. Will this higher clock rate translate in real speed? Last but not least, number 4, a development board with an ESP8266 chip and a clock rate of 80 MHz.
But why do I call this board Arduino compatible? Because you can use very much the same code to program them. If you prepared your IDE accordingly, it takes care of the rest. Many standard libraries are already ported and are selected automatically. You just have to pay attention to minor differences. For example, for the ESP8266 board, you have to use the names D5 for pin 5. The other boards understand also 5. The LED on all Arduinos are on pin 13. The Maple LED is on pin 33. You can use compiler macros to distinguish between the different architectures as shown in my code. I will show you now how easy the code is compiled and uploaded to the different boards.
Let's start the race. Round number 1, code for sensors and relays. Ready? Go! This was a fast race. The 2 30-bit racers went extremely fast, while the older 8-bitters are still on the track. Here is the table with the results. The fastest was the ESP8266 and it was 12 times faster than the slowest. Incredible! As a comparison, I added the results of the Arduino Uno for the 8-bit generation and the results for Arduino IDE for the 32-bit generation. Now let's do the number crunching race. Will the 32-bitters profit from their wide data structure? Ready, go! Again, the 32-bitters were extremely fast. Here are the results. The difference between the fastest and the slowest is smaller. Is this because I use the data type double, which is very precise? It is well known that the 8-bitters ignore this structure and replace it with a less precise float data type. Let's compare the results of float with double. The 32-bitters crunch float a little bit slower. This is unexpected to me. In the future, I will therefore always go with double. If you compare the code of race 1 with race 2, it is clear how much resources are used by floating point arithmetic. You can do a lot of things just for one floating point formula. Now let's compare the power consumption. Here, the slowest board is definitely the winner. If you do not need speed, the slow 3.3 volt Mini is your choice. The ESP8266, on the other hand, uses a lot of energy for the VLAN. So, this is a choice if you need connectivity. A good compromise is the Maple Mini. It is extremely fast, has a lot of pins, and does not need much power. This is why I use this board for my GPS tracking project. I hope this episode was useful for you. Bye!